If you watch my videos on my channel, you could have stumbled across the video that was showing Morse code encoder. In this video, I created a device used to input text and then translate that input into Morse code. To input the text, I use OLED display, potentiometer and two push buttons as shown here. I am working on a similar project that requires text input, but this time I thought I would use this 5-key keyboard module instead. I will try to figure out how it works and then adjust the code, replace potentiometer and push buttons with that single keyboard module. So here is that 5-key module. Doesn't look too complicated. Simple custom PCB with 5 push buttons. We can also see few resistors. The module has 3 pins. You have ground and VCC pins, just one data pin that is going to provide 6 different states of this module. 5 for the press of each button and the 6th one for no button press. I don't know much about this module. It was purchased on AliExpress together with other components. It did not come with any datasheet. So before we start adjusting the code of the device I originally built, we have to figure out how this part actually works. For any device providing multiple states with a single data pin to Arduino, this can be achieved in 2 different ways. Through digital input, meaning the sequence of high and low signals, sending either 0 or 5 volts to Arduino input pin. In this case, each state is represented by a defined number of 5-volt impulses. If you are not new to my channel, you have probably seen the video about programming coin acceptor. This is a perfect example of a device which is representing different recognized coins with different number of impulses. Those digital impulses can then be processed by Arduino with either digital read command or by using interrupts. I suspect this is not going to be this type of the device. It just looks too basic. So that brings us to the second method, which is the analog input, where the device sends to Arduino voltage values ranging from 0 to 5 volts. Here, pressing each button would result in outputting specific voltage value at the data pin, which can then be sent to Arduino and read with the use of analog read command. In order to test if I am dealing with a digital or analog device, I need to connect the module to Arduino, connect serial monitor and see the output this module produces myself. Connectivity is that simple. The module ground goes to Arduino ground, module VCC goes to Arduino 5 volts. I will connect data pin to analog pin A7, which can be used as both digital and analog input. So let's first make sure we are in fact not dealing with a device producing digital output. In the code, we label the A7 pin to which the keyboard pin is connected as key pin. In setup function, we configure this pin as input. We also open serial monitor so we can output values read at the pin A7. In main loop, we have just one command which sends the value read at the pin to the serial monitor. Okay. So I am now pressing the buttons and I don't really see any changes in the serial monitor. So it is definitely not digital input to Arduino. So we can move on and treat it as analog device. We need to adjust the code, drop pin mode command, as with analog read, the pin in question is by default treated as an input pin. In main loop, I replace digital read command with analog read one. So straight from the bat we see that value 1023 is read at the pin when no button is pressed. It corresponds to 5 volts, as when we are using analog read command, the input range 0 to 5 volts is converted to values ranging from 0 to 1023. And when I start pushing buttons, you see a pattern of specific values in the serial monitor. Let's capture the values for each state. I actually would use ranges of values, so we do not have issues if those values fluctuate a bit. And you can see they do. So now let's write the sketch that properly identifies which button was pressed. Again, key pin label is assigned to pin A7. Key read variable stores newly read input from the keyboard. Previous key variable would store previously read state of the keyboard for comparison, allowing us to detect the change of state. Key ID variable holds the string that describes which key was just pressed. So left, right, up, down, and select. We would output this value to the serial monitor to see the sketch works okay. In setup, we open serial monitor. Now to the main loop. First, we read the keyboard state into the key read variable. Then we have a sequence of if statements which check the key read value against previously defined ranges, and when the right range is detected, assign the right value to the key ID variable. We would send the information to the serial monitor only when the key read value changed since the last loop run and the key read is smaller than 1000, as values larger than 1000 indicate idle state, so no button press state. And here, with print command, we are sending relevant information to the serial monitor. Println adds carriage return to the end of the sent information, so next information would start from a new line. We save value of key read variable into previous key variable. It will help us to detect state change in the next loop run. Let's test it. All 5 states were properly identified, so I guess we are ready to incorporate this code to original data input sketch. Let's connect OLED display to our current setup. Starting with VCC and ground, then clock pin goes to analog pin A5 and data pin goes to analog pin A4. While I am connecting the real thing, it is perfect opportunity for you to hit that like button. That is of course if you like this video, and if you are still watching it, I presume you do. It is super important and it helps to grow my channel. Okay, connected. Before we can start adjusting the code, let's quickly go through setting up OLED display and displaying the graphic design of the keyboard on it. If you get lost on the way, probably would be a good idea for you to watch my OLED tutorial as well as the video about Morse code where I built the first prototype of this text input device. We would need following libraries. Then we declare size of OLED display and declare the display itself. Then we need a bunch of variables. This time we label analog A7 pin. Then we have variables to store coordinates of the character that is currently selected, as well as coordinates of the character that was selected previously. Then we have key read variable that stores current state of the keyboard, as well as pre-read variable that stores previously recorded state. We also have toTransmit string variable that stores the string that was entered using our device, as well as toTransmit length, which holds the length of that string. We finally have an array 9 by 3 in size that stores all possible characters that we can enter. So with that out of the way, we can go to setup function and start creating the design of the keyboard. First, we run display statement that is used to refresh the screen with the new content. First execution always outputs Adafruit splash screen. Then we clear the screen. Next, we draw a frame at the top of the screen that would store the text input. We draw a smaller box to the right, which would serve as an OK button. Next, after changing the font size, we loop through the letters array and output all possible characters to the OLED screen. So we would have 3 rows and 9 columns. And finally, we highlight the character in position 00, which happens to be a letter A, that becomes our initial cursor. A quick reminder how we are going to navigate cursor through that key map. Each character has its X and Y coordinates and is located in the rectangle, which has a defined width and height. When the cursor position is to change, we invert rectangle of the currently selected character, seemingly unselecting it, and then we invert the rectangle of the new character to be highlighted, and that results in cursor moving to that position. We'll move cursor with the use of highlight letter function. This function has 4 arguments. First 2 describe coordinates of the highlighted letter after the cursor move, and the last two describe coordinates of the highlighted letter before cursor has moved. The x coordinate has a range from 0 to 8 and y coordinate has range from -1 to 2. -1 representing top panel with the OK button. So if we want to move the cursor from A to B, we need to execute following command. So finally we can incorporate keyboard control code to main loop function. We read keyboard state to key read variable. Then we check if prev key read is larger than 1000, meaning during previous loop run no button was pressed. And new read is smaller than 1000, meaning one of the 5 push buttons is currently pressed. If this condition is met, we proceed further. Now we use the sequence of if statements that identify which button was pressed that we used in previous sketch, but instead of outputting the result to the serial monitor, we adjust cursor coordinates instead. The last range is linked to the select button. For now, we would assign no action to it. And then, if the coordinates were changed and are within the 9x3 key map, we are using highlight letter function to move cursor to the new position. After this is done, new position becomes previous position, so it can be referred to in the next loop run. Then we update the content of the OLED display with display commands and assign current read from the keyboard to the prev key read variable. Let's give it a try. Works great. So now, let's add some special behavior for navigating to and from top panel. When new y coordinate is -1 and old is 0, that means that we moved from the first row of letters to the top panel by pressing up key. In this case, we invert the OK button so it is highlighted and unhighlight the position we were at when the up button was pressed. Here you can see it on the actual display. Now that we are in the top panel, we have an option to move from the top panel back to the first row. Here the new y coordinate is 0 and the old one is -1. We deselect OK button and highlight the letter in the first row that corresponds to current x coordinate. Here we also save current position to the old position coordinates. So now that we have cursor navigation sorted out, we can go back to that if statement that identifies select button being pressed. We have two possible actions. First, when the button is pressed while the cursor highlights one of the letters. In this case, we are adding highlighted letter to the toTransmit string and increase variable toTransmit length. Then we adjust the font color and size, clear the top panel and display toTransmit string on it. The second possible action is when we press select while OK button is highlighted. This action would depend on what we would use this text input device for. It can open magnetic lock if the proper password was entered, or we can transmit the text in some way, e.g. like I did in Morse code video. In this video, we'll just blink the top panel a few times. So here's the block of code that will do just that. So now it's time to test end-to-end process. First, we'll enter toTransmit string. When done, we'll navigate to the top panel and highlight OK button. Now that we press select button, the top panel containing the toTransmit string would blink few times. Works as expected. This is the end of this video. I hope you like it. If you find this device useful and you would incorporate it into your project, please let me know what you used it for in the comment section below. I would like to thank all my viewers and subscribers for supporting this channel. It's truly amazing. It is not even 2 weeks since I crossed 1000 subscriber mark and I have already surpassed 1200. The growth is amazing, so I hope to see you in my next video. Over and out.